So, before we learn how to simplify algebraic expression, first of all, we need to learn how to distinguish constant terms, like terms, and unlike terms. Basically, constant terms are terms that are numbers only. Like terms are terms that contain the same letter with the same index. And unlike terms are terms that are not like terms. And what does that mean? We can look at some examples here. Let's say -2 and 1 are constant terms, or any numbers without any variables attached to it. For example, 9, -3, 25, 20, all these can be constant terms. And for like terms are these examples: 3x squared and 8x squared. Why are they like terms? They have the same letter and the same index at the letter. So it means even if we have two terms with x, it doesn't mean that they must be like terms. We also need to look at the index attached to it. And let's say another example is 4xy and 6xy. They are also like terms, because both of these terms have the same letters plus the same index for the letters. And of course, all constant terms can be like terms. And examples of unlike terms are all this: 3x squared and x, because even though both of them have x, their index are different. And 6x squared and 8x cubed are also unlike terms, because both of them have x, but the indexes are different. Also, you can randomly raise any examples of unlike terms. Let's say 6x and 8x squared, or 6 and x squared, or 3x squared and 9x to the power 4. So there are many other examples that you can raise randomly. And now, here are some algebra expression on the left column. And we are going to do it as an exercise to find out what are the constant terms, what are the like terms and unlike terms. So start with the first one first. For constant terms here, according to the definition, 4 should be the constant term. And for the like terms, for terms with the same letter and also the same index, are p and -6p. So bear in mind that when we look at a term, we also need to take into consideration the coefficient in front of it, including the minus sign or plus sign. So if it is just plus 6p, we can simply just write p and 6p. But because here there's a minus sign in front of the 6, so we need to write as a whole minus 6p as the term. And one pair of unlike terms are 4 and p, or we can say 4 and minus 6p are unlike terms. So let's look at another example. For the second example, constant terms, of course, -6 and 2 with no variable attached to it. And like terms with the same letter and same index can be 5q and -7q. Or another pair of like terms could be -6 and 2, because both of them have no variable attached to it. And unlike terms can be many examples. Can be 5q and 2, or -7q and 3q squared, or 5q and 3q squared. They have the same letter and different indexes, so they are unlike terms. So maybe you can try the third example as an exercise. For the constant term, first look at which one only have a number, or no matter whether it's positive or negative number, but without any variable attached to it. For the like terms, they should have exactly the same letter plus exactly the same index. So, first of all is minus 8 should be the constant term. For like terms, the only possibility is r squared and 7r squared. Unlike terms, there can be many. Here we just raised one example is 3rs or 3rs and 7r squared, or 3rs r squared, or randomly pick another one is minus 8 or 6r. So there are many possibilities of unlike terms. So why are like terms important? It's important because in simplified algebra expression, when we do addition and subtraction, we can only do it between like terms. For example, if we need to add 3x and 4x, because they are like terms, we can group them together as 7x. 5a minus 2a, we can subtract them and it's 3a. But for example, if there is 3x and another term is 4x squared, because 3x and 4x squared are unlike terms, and in that case, we cannot add them together. So let's take this as an example and exercise. If we need to simplify the following algebraic expressions, first of all, let's look at part A. We need to find out which are like terms. For example, unlike terms are x and 1, and there's no way that we can add them together. We need to separately write them. But for x and 3x, they are like terms, so we can group them together as 11x, or we can say we add them together, 11x. Also, 1 and minus 7 are like terms. We can simply subtract 1 by 7. So the final answer should be 11x minus 6. And the grouping should be x plus 3x we can group like this, and 1 minus 7 we can group like this, because both of them are like terms. Or we can even do it just mentally and write the final answer. And for part B similarly, we first search out which ones are like terms. 7x and minus 5x are like terms. So we can put them together. Minus 3y and 6y also like terms. So basically it's 6y minus 3y, or we can say minus 3y plus 6y. It gives 2x plus 3y. This is why it is so important that we need to figure out what are the like terms and unlike terms, as it is especially useful in addition and subtraction of algebraic expressions. And the good news is, in multiplication or division of algebraic expression, is not limited to like terms only. Even unlike terms, we can multiply them or divide them. Like 5y times 2, we can simply just multiply the number parts, and it gives 10y. And 18y divided by 3 is 6y. So it's very simple. And now let's take a look at some examples again. On the left-hand side, there are some algebraic expressions, and we need to find out the number of terms, the constant terms, and the like terms. So obviously here, for the first example, there should be 4 number of terms. 4 terms altogether. And the constant term is 7. All the like terms. For the like terms, we need to look at which terms have exactly the same letters and also exactly the same index. So x cubed z is the same as this x cubed z. So the only like terms are 6x cubed z and minus 4ez x cubed. Even the orders are different, but as long as the index are the same, they are like terms. And other examples are similar methods. For this one, there are 1, 2, 3, 4, 5 number of terms. 5 terms are there. The constant term, the only constant term is minus 11 here. And the like terms, look at one by one. CD have same letters, same index. But CD square cannot be like terms with CD. But CD square is the like terms with another CD square. So the like terms pairing up should be xcd and 10cd, minus 6cd square and 7cd square. These two are two pairs of like terms. Another example, example 3, there are 1, 2, 3, 4, 5 terms here. And the only constant term here is minus 17. Again, we need to take into consideration the minus sign. And for the like terms, the only pair of like terms should be 3xy and 11xy. For others, you can see x squared y squared cannot be like terms with xy cubed. Also cannot be like terms with xy. And the last example is this one. The only constant terms should be minus 11 and 6. And there are altogether 4 terms. And because for the terms with letters, their index are different, m squared n and mn. So these two terms are not like terms. The only like terms are minus 11 and 6 again. So let's take a look at another exercise together. For part A, first of all, we need to figure out which are the like terms. There are 2m and 6m, also 8n and minus 3n. So the answer should be 6 plus 2 is 8, and 8 minus 3 is 5. For part B, the like terms can be grouped together first. 6d minus 8d, and then minus 18e plus 11e. So the answer should be minus 7e, because minus 18 plus 11 is minus 7. And also 6d minus 8d gives minus 2d, and then plus 9. And so forth. For part C, first of all, we need to deal with the division and multiplication first. So the second and third term would give rise to minus 4y. And the last two terms would give rise to minus 15y. So the first step would be 10y minus 4y, which is minus 16y divided by 4, plus 8, and then minus 15y. So the final answer should be 8 minus 9y, because 10 minus 4 is 6. 6 minus 15 is minus 9. And so forth. We can see from part D, 6r times r would be 6r squared. And then this 6r squared would be like terms with minus 4r squared. So the next steps can be 6r squared plus 24s minus 4r squared minus 3s, because 9s divided by 3 is minus 3s. And grouping the like terms together, 24s minus 3s is 21s. 6r squared minus 4r squared is 2r squared. That's it. And part E is a little bit interesting. For they are very similar. They look very similar. But you can see that a cube b with this ba cube, actually they are like terms. Because the index for a are the same and index for b are also the same. So we can group together 8a cube b and minus 4a cube b as well. The next step would be 4a cube b and the minus 6ab cube will be kept like this and then plus 2. For part F, again, you can see that sometimes even the letters have different orders, but if their indexes are the same, basically they are like terms. You can see that mn squared, here is also mn squared. So, these two are like terms, but m squared n, because all the other m only have 1 as the index. So this one cannot be like terms with others. So the next step will be 6 minus 7 gives rise to minus 1 and minus mn squared. Also 2m squared will be kept, 14mn will be kept, and then the final answer should be like this. So these are the answers for the exercise of these algebraic expressions. And last but not least, for simplifying algebraic expression, we can also try to translate English sentences about an algebra into mathematics languages. For example, represent each of the following word phrases by an algebraic expression. Basically, when we write in English, it will be very long and clumsy. Let's say part A, add 24 to 6xy, we have to write 4 words. But if we translate into mathematical languages, it would be 6xy plus 24. So it's much simplified. For part B, subtract b from the cube of a and then divide the difference by 6. So actually cube of a can be represented by this form. And then subtract b from this item is a cubed minus b. And then divide the difference by 6 is divide the whole thing by 6. So in this way is a mathematical language. This sentence is English language. Basically, we can translate English into math, and math language is much more simplified in terms of algebra. So part C, add 5 to the product of square of x and z. You can have a guess first. Square of x, of course, is x squared, and product of x squared and z is x squared times z. And add 5 to the product. In the whole, we can write in this way, a simple form. And part D, subtract the quotient of dividing 18 by y from the product of 7 and x. So product of 7 and x is 7 times x, or 7x. Subtract the quotient of dividing 18 by y. So altogether we can say 7x minus quotient of dividing 18 by y is 18 18 divided by y is this quotient, and subtract the whole thing from product of 7x. So that's all. This is the initial parts about algebraic expression and how to simplify them. And of course, we can have many more to come, which are about, for example, transposing terms, and also other more complicated cases of algebraic expressions and how to simplify them. Thank you.